Alright, in this video I'm going to go over the answers to the second question. So we start with this one, state the principle of conservation of momentum. So we need to remember that let me just grab a pen. So the total momentum is conserved, and that's the first point. Maybe we'll say total momentum of a system. Is conserved. And then the second point, marking point here, is going to be that if no external forces act on the system. So always check for these questions. If there are 2 marks, then there are 2 distinct points that may need to be included. Alright, now we have this situation where a pellet is fired into a block, and it causes the block that was initially stationary to slide along the top of a bench, and we're told that it slides a distance of 2.8 meters, and we're given all this data about the situation. So I'm going to solve this just below so I can see all the information. So we have, this is what is it, 2b, 2b1, 2b1. So show that the initial speed of the clay block after the air rifle pellet strikes it is 4.8 meters per second. So immediately after the air pellet strikes it, it won't have had time to lose any momentum because of friction, and so this is just a conservation of momentum question. So we look at the initial situation. So initially we have the little pellet and we have the block. The pellet is moving, and we can say that Pi is just going to be equal to the momentum of the pellet. So that's just going to be m pellet times v pellet, and the pellet was 2 grams, so that's 0.002 kilograms times the speed of the pellet, which is 140, which gives us a total initial momentum of, let's get our calculator up here, so 0.002 times 140, which gives us 0.28 kilogram meters per second. Okay, and then we look at the final situation. We have the pellet now embedded in the clay block, so we have their combined mass moving, and the whole thing is moving that way with some speed v. I'll call it v total. So here we have Pf, and that's going to be the combined mass here, which is 0.002 plus the mass of the block, which was 56 grams, so that's 0.056. And we're going to multiply that by the speed to get an expression for the final momentum. And then we say, if no external forces act, total momentum is conserved. Okay, and so we have Pi equals Pf. So we have 0.28 must be equal to 0.058 times v. So v is going to be equal to 0.28 divided by 0.058, which gives us, so 0.28 divided by 0.058, which gives us 4.83. 4.83 meters per second. And let's just check how many significant figures we should have had. Well, these things were only given to 2SF, so we should really be at 2SF. So that's equal to 4.8 meters per second to 2SF. Okay, so that's B1, so that was 3 marks. B2, show that the initial speed of the clay block after, number 2 is calculate the average frictional force that the surface of the table exerts on the clay block whilst the clay block is moving. Alright, so we have a couple of options for how to do this. We could either look at the change in momentum, but I think it's probably best to do it and to figure out the acceleration first. So if we have, we know that the total force has got to be equal to m times a, and we're given enough information to find a here. So we already know the mass, so we can find find a. So in order to find acceleration, we need to know a few things about the motion. We know its initial speed, we've already worked that out here, and we know its final speed is 0. So we know u is equal to 4.83. I'm going to use the slightly less rounded one so that I can be sure that my final answer is going to be right. We know that v is equal to 0 because it's going to stop. And we know that it moved a distance of 2.8 meters, so s is equal to 2.8 meters. So we know 3 things, and so we should be able to find a. So a is the one we're trying to find. So here we know that, which equation will we use here? We'll use v squared equals u squared plus 2as. And we know that v is 0, so we then get 0 minus 4.83 squared divided by 2s, so 2 times 2.8. That should give us a, and that is equal to, so 4.83 squared negative divided by 2 times, not times, we need a bracket there. I'll have to start again. So we go 4.83 squared negative divided by 2 times 2.8, which gives us 48.59. That seems quite big. Let's just have a look at that one more time. 4.83 squared negative divided by 2 times 2.8 gives us negative 4.166. Negative 4.166 meters per second squared. Okay, when you plug something into the calculator, just check that the number makes sense. So I saw here, this should probably be sort of between 16 and 25, obviously, and this should be about 5 point something. And so that my answer of 40 something was ridiculously large. And so the last step then is to go F equals ma, which in this case is equal to 0.058 times, I'll say negative 4.166, which gives us negative 0.24 newtons, but we were only asked for the oh no, that's right. So basically this is our answer. So it's negative because it's acting in the opposite direction to the speed that we were talking about. Okay, so then 2c, I'll just go a little bit off to the left here. Let's just read it first. So discuss the energy transformations that occur in the clay block and the air rifle pellet from the moment the air rifle pellet strikes the block until the clay block comes to rest. Okay, so which number was this? This was 2c. So 2c, so the pellet's initial kinetic energy is converted to a combination of heat as it kind of slides into the block, and we're going to call that energy internal energy of the block and pellet. If you'd said heat, you would have gotten full credit for that one at this stage. But once we've done thermal physics, which is our next topic, we'll learn that we're actually going to call that internal energy. Okay. Internal energy of the block and pellet, and kinetic energy of block and pellet. As it enters the pellet, as it enters the block. Then we have a second motion here where the thing slides along the surface, slowing down. So as the block slides over the surface, its kinetic energy is converted to heat due to the work done by friction. And then we might make a statement about the final situation. So when the block is stopped, all kinetic energy has been converted to heat and internal energy. At this stage, I'm going to give full marks for converting to heat, because we haven't really talked about internal energy yet. I'm not going to, you wouldn't lose any marks if you hadn't talked about it in here. Okay, so that's C. Then we have one last question, D. The clay block is dropped from rest from the edge of the table and falls vertically to the ground. The table is 0.58 meters above the ground. Calculate the speed with which the clay block strikes the ground. Okay, so this is a, we can do this either with energy conservation, or we can do it with the kinematic equations. Because we know the acceleration is going to be 9.81, the distance, s, we know, and we know that the vertical speed initially is 0, so we can find the final speed that way. I'm going to use the energy conservation method here, and maybe I'll show you the other one as well. So 2D, we have the block is here, and it's going to move to here. This distance here is 0.85 meters, so delta E P must be equal to delta EK. So mgh, or mg delta h I should say, mg delta h must be equal to half mv squared. We can cancel the m's here to make our calculation a bit more simple, and then just rearrange for v. So v is going to be equal to the square root of 2g delta h, which is equal to the square root of 2 times 9.81 times delta h, which was 0.85, which gives us a final answer of, so we go 2 times 9.81 times 0.85 equals, and then we'll take the square root of our answer and we get 4.1. 4.1 meters per second. Note that we could have done this another way. I'll do it the other way as well. Or we could have gone A equals 9.81, S equals 0.85, U equals 0, V equals something. Then we could have used V squared equals U squared plus 2AS. And we know that U was 0, so we get V is equal to the square root of 2AS. And you'll see that this is actually the same thing that we had here. So that's equal to the square root of 2 times 9.81 times the change in height, which is 0.85. And we already know that that's 4.1 meters per second squared. Okay, either method would have given you full marks for that question.